Guys, I'm going to show you the derivation of electrical conductivity of metal. So, expression for electrical conductivity of a metal. So, we are going to see a derivation. For this, what you have to do is you have to assume a metal. You know that metal consists of so much number of free electrons which moves randomly. You can see this is a metal. You can take any metal, either gold or silver or any metal, okay, or copper, any metal. So do you know that metal consists of free electrons? These free electrons are moving randomly in the absence of electric field E. So I'm specifying a vector because electric field is having both direction and magnitude. Now we are going to assume a metal in which this metal is given with the potential difference. So this is positive terminal and this is negative terminal. This is positive terminal and this is negative terminal. If you apply electric field to the metal, all the electrons present in the metal will move towards the positive potential. You know that electrons are negative charges. So when it is connected with the electric field, all the electrons will move towards the positive terminal of the battery. So the electric field will flow opposite to the flow of electrons. Okay, so what you have to consider for the expression of for the electrical conductivity of metal, you have to consider a metal and you have to apply electric field. This is in the presence of electric field E. This is absence of electric field. This is in the presence of electric field. So in the presence of electric field, what's happening? The electrons will move towards the positive potential and the electric field will move opposite to the potential. So now we are going to derive the expression for the electrical conductivity sigma. Okay, sigma is the electrical conductivity. So we are going to derive the expression for the electrical conductivity. For this, what we have to consider, when an electric field is applied, the electrons will move in a velocity which is known as drift velocity. Drift velocity, and it is denoted by the letter V suffix E. So what is this drift velocity? When we apply electric field, the electrons will acquire a velocity and it will move towards the positive potential of the battery. The velocity acquired by the electrons are known as drift velocity, and we know the velocity is equal to distance by time. What is distance? It is lambda, that is mean free path, divided by time. In classical mechanics, time is given by tau. Time is given by tau into c, where it is known as collision time. So drift velocity is given by lambda divided by tau c. Lambda is distance, tau is time. Okay, so now force experienced by the electron because of electric field is given by F is equal to E suffix E. F is a vector, E is a vector, where F is force, E is charge, capital E is electric field. This is equation 1. Now, according to the Newton's law of motion, the force on electron is given by F is equal to ma. This means this is the Newton's second law of motion. First equation is force experienced by the electron, and the second is Newton's second law. So F is equal to ma. So both are force, both equations of force. So we can equate this equation. Ma is equal to E, where m is mass, a is acceleration. So acceleration is given by charge electric field divided by mass. This is equation 3. So we know in the presence of electric field, the drift velocity is v suffix d is a drift velocity, and from the formula Vd is equal to lambda by tau c. So if tau c is the collision time, then acceleration. Why we are talking about acceleration here? Because when you apply electric field, the electrons will get accelerated and it will move towards the positive potential of the battery. So we have to talk about the acceleration. So acceleration is nothing but velocity divided by time. So what is the velocity over here? It is drift velocity. So Vd, what is the time? It is tau. Okay, so drift velocity is equal to a tau. Okay, so what is this is equation 4. So what is the acceleration? Already we derived acceleration is E, capital E divided by m. Now substitute v suffix d is equal to a e divided by m into tau, which is equal to e tau by m into E, capital E. So this is equation 5. So now I'm going to shift to the next equation. We know that this is the another relation for current density. J is equal to n e v suffix t. That is, n is number of electron, e is the charge, v suffix d is the drift velocity. This is equation 6. So now we are going to substitute equation 5 in equation 6. So J is equal to n e, what is equation 5? E tau divided by m into E. So I am going to substitute E tau divided by m into E, or J by E is equal to n e square tau by m. This is your equation 7. So J by E is equal to n e square tau by m. So we know that, we have already seen that J by E is equal to sigma. So instead of J by A, we can substitute sigma is equal to n e square tau by m. So this is the equation for electrical conductivity of metal. Sigma is the electrical conductivity, n is number of electrons, E is the charge, tau is the time, m is the mass. So sigma is equal to n e square tau by m. This is equation 8. This is your equation for electrical conductivity of a metal. Thank you guys.